Hi, my name is Helen, and today I'm going to be sharing with you my 3 ways of solving this problem. The problem says that a semicircle is inscribed in an isosceles triangle with base 16 and height 15 so that the diameter of the semicircle is contained in the base of the triangle as shown. What is the radius of the semicircle? So, if a semicircle is inscribed in an isosceles triangle, that means that there are going to be 2 tangent points here and here. So if you connect the tangent point to the center point of the circle, you get the radius, which I've done. And then these 2 angles are going to be right angles because of the property of tangent point. And we can call this bit x over here. And because it's an isosceles triangle, this triangle is half of the bigger triangle. So that means that this part, which is half of 18, which is 8, and 8 and 15, this is a right angle. We have to find this side. And we know that 8, 15, 17 is a Pythagorean triple, which means that this side is 17. So we can finally start with method 1, which will be using area. So the area of half of the bigger triangle is going to be 8 times 15 over 2. But because it's going to be a denominator, I'm going to take out the denominator. So it's just going to be that 8 times 15 equals to this tiny triangle and this other triangle. So that means that 8 times 15 equals to rx plus 17 minus x times r. So then hence that 120 equals to rx plus 17r minus rx, which means that 120 equals to 17r, and that means that r equals to 120 over 17. That's a very simple way to solve for r in this problem, and we can move on to method 2, which is more complicated. We'll be using the Pythagorean Theorem to be finding r. So basically, if we focus on this tiny triangle down here, we have that 64 equals to x squared plus r squared. And focusing on this triangle over there, we have 17 minus x squared plus r squared equals to 225. That means that this, once you simplify it, is 289 minus 34x plus x squared. Now, 2 equations, 2 variables. There are 2 ways you can solve for the 2 variables. Either use substitution or you subtract the 2 equations. So I'm going to use substitution here, and we're going to substitute r in terms of x. So that means that 289 minus 34x plus x squared plus 64 minus x squared equals to 225. We can cancel out the x squared, and we get that 289 plus 64 minus 34x equals to 225, which means that 353 minus 34x equals to 225, which means that 34x equals to 128, which means that x equals to 64 over 17. So this is only x, and we're trying to solve for r, so if we plug x back into this equation, then we get that 64 equals to 4,096 over 289 plus r squared, and we can convert 64 to a mixed to an improper fraction that has a denominator of 289. So that means that 18,496 over 289 equals to 4,096 over 289 plus r squared, which means that r squared equals to 18,496 over 289 minus 4,096 over 289. So, which means that r squared equals to 14,400 over 289. To find r, we simply have the square root of this, which equals to 120 over 17. This method involves a lot more calculation than the first one, and I don't recommend this method for this problem. I'm moving on to method 3, which is going to use similar triangles, or if you already know the projection theory, then you can find it. But if we focus on this triangle, this half triangle, when we rotate it, that 17 is the base, you get this triangle, and this triangle might look familiar because it's it's a projection theory. So, but assuming that you don't know what it is, I'm going to solve it using similar triangles. So, we see that triangle ACD is similar to triangle ABC. So, we get that 15 over 17 equals to r of a. That's all we need to know here, which means that 120 equals to 17r, which means that r equals to 120 over 17. And that's my 3 methods for solving this problem. Thanks for watching.